There are numerous different types or classifications of matrices that exist. I just want to highlight some of the few main ones that we should be aware of as we're just getting our feet wet with matrices. So one type of matrix that we should be aware of is a matrix that is rectangular in nature. So basically what that means is the dimensions of the matrix should be some number m by some number n, right? So m and n could be different numbers. So obviously the matrix might look, something like this, where the dots are just supposed to be where the elements are going to go. So like that would be a 3 by 5 matrix, of course, right? Now, it would also be rectangular if m and n actually were the same number as each other, but we could kind of simplify that. So we would call it a square matrix if you had the same number of rows as you had columns. So like that would be a square matrix because it's like a 2 by 2 sort of matrix. So we have those types of common matrices. And then other matrices that you're going to want to be aware of is when you have a matrix that has just a single column, or if you have a matrix that has just a single row, like you're seeing there. So like this matrix would be a 4 by 1 matrix, and this matrix would be a 1 by 6 matrix. So we would call these types of matrices a column matrix, and then these types of matrices here a row matrix when there's just a single column or there's just a single row in the particular matrix. All right, and then getting into some operations now with matrices. So it does turn out that we can do some of the operations we normally do in math, like adding and subtracting and such with matrices. So just for right now, starting with addition and subtraction. So it does turn out that in this particular problem right here, you're really just trying to add two different organized data sets. And so the way this works is you just add the corresponding elements together with one another. And so you just want to add together those particular elements together with each other and come up with the sum. So if you do 1/3 plus negative 2/3, you're going to end up with negative 1/3, and then you can add together the 4 with that 4, and that's going to give you a sum of 8. And then we're able to add together the negative 4 with the negative 4, which is going to give you negative 8. And then moving down to the next row, we have a negative 1.5 plus a positive 10.5. That gives you a sum of positive 9. And then we're able to do 4 and negative 4, which adds together to equal 0. And then finally at the very end there, we've got x squared plus 5 plus 1 minus 3x squared. So it's just kind of combining like terms. So if you did x squared plus negative 3x squared, you'd end up with negative 2x squared. And then if you did positive 5 plus 1, you get 6. And then you get that algebraic expression right there. So that matrix right there gives you the sum of those two particular matrices. It does also turn out that you can subtract matrices, and you just subtract the corresponding elements. Be careful when you're subtracting, though, because sometimes you end up with, subtracting a negative or all that sort of stuff. So just got to be really cautious about that as you're proceeding through this. So starting with the first pair right here, you're noticing that you're taking a positive 19, and then you're doing the operation of subtraction of 15. So you got to think 19 minus 15, and what is that going to equal? It's going to equal a 4. So we end up getting a result of positive 4 in that first position right there. And then proceeding to, let's say, this element and that element in corresponding spots. What you're trying to do is you're trying to do 10 and then your subtraction operation, and then the number you're subtracting is a negative 5. And so since you're trying to do 10 minus negative 5, it's really 10 plus 5. So you end up getting 15 in that particular spot. And then if we take the negative 7 and the negative 2, we start with a negative 7. We're doing the operation of subtract, and then you're subtracting a negative 2, which means negative 7 plus 2, and that ends up equaling negative 5 when you finish that operation. And then last of all, we have, let me get the right color here, this negative 3 and then this 4. So if we start with a negative 3, and then we're going to do the operation of subtract a positive 4, then negative 3 minus 4 is going to give you a result of negative 7. So that gives you the answer to that subtraction problem between the matrices. And then this last problem right here looks interesting, and it's a little different than the prior two because the dimensions of the matrices are not the same. So it actually turns out that you're actually not able to perform this operation. This would be an undefined operation. So in order to add and subtract matrices together, the matrices need to be exactly the same dimensions. So yeah, this would be impossible to do. Like, this is an undefined operation. So it's just something that we're not able to actually get an answer for, and we can't perform that operation. So as you can see up here, it says that two matrices, you can only add and subtract them together if and only if they have the same dimensions as one another. So that's a really important aspect about being able to add and subtract matrices with one another.